This is part 4 of a 1 hour and 40 minute recorded Twitch stream from the 16th of April 2020, where we discuss the various MPLS VPN building blocks from a design perspective. In this session, we will validate the MPLS Edge design by inspecting the VRF configuration for 2 customers, including the PE to CE routing. We hope that you enjoy the video, and if you do, please let us know by providing a like, comment, or telling anyone you know who may be interested. So, if we move on to the next part of the puzzle, okay, we've got this VRF configuration, and this is actually VRF configuration underneath BGP. If I look at there's things that we need to do first, right, in order to create a VRF. So a VRF, what that's doing in the wider scale of this design is we might have, multiple services or multiple customers on a multi-tenanted site. So the green line might be customer 1, the purple line might be customer 2, this line might be, it's a terrible colour to mix it in, but you get the picture. Those 4 lines, the green, the purple, the red and the sort of maroon colour, they might be 4 separate customers, or it might be green is customer 1, purple is customer 2, red is a SIP service which everybody shares, and this one at the bottom is an internet service that everybody shares. And that terminates onto a firewall, that terminates on a session border controller, that goes down a VLAN trunk to customer B, and that goes down the VLAN trunk to customer A. And that's how the segmentation is provided. So those VRFs are configured on, basically the customer facing interface. It might be a single link, and more likely to be a single link with multi-VRF configured in effectively VLANs. But I'll show you that in a second, because I've configured that on the lab environment. So if we how do we actually do that then? So I've got, in the example scenario, I've got this router down here, in the top left, which has got customer A and customer B on it. Alright, and then if I need 2 VRFs certainly on the PE node. So I've got, let's say the green is customer A and the purple is customer B, right, in this diagram. So how do I actually achieve that? The first thing that I need to do is configure the VRFs. Show run VRF. Oh yeah. Right, so the first thing that I'm doing here, right, is I'm defining the VRF. So the configuration, as I go into configuration mode, I do conf t, then I do VRF A. So it's slightly different. In iOS you do VRF definition, but in iOS XR it's VRF A. We then have to say which address family we want to use it with. So because we're facing the customer this time, we're not doing VPN v4, we're doing IPv4 unicast, but we're doing IPv4 unicast for a specific VRF and via a specific customer. So we're saying we want to use IPv4, we want to just exchange IPv4 because that's what that's the language that the customer talks. We then define our import and export route targets, so that tells BGP which routes we want to import and export into the VPN from IP and between different VRFs. And that's it for defining the VRF. And you'll see I've repeated that configuration. Then I've got VRF B. You notice that my route targets are different. If I configured a VRF B and then I made the import 1.1, then that's how you would get customer A's routes in customer B's routing table, and it's how you perform like extranet type MPLS services for shared services, but we'll not get into that because we've not got enough time today. And then VRFC is the same, but the route target about what the import and export route targets are 3.3. So very simple example. So the first thing is to create the VRF. The next thing that we need to do is interfaces, show VRF all. I think this tells us which interface. So this is VRFA, show VRFA detail. So VRFA tells you the route distinguisher, which we'll get onto in a minute. But the interfaces that are in there are gig 0015 and 0015. So if you look at this diagram on the left hand side, you see gig 0001 is the interface of the PE, which is facing the CE router. So what I would then do to show you anyway is, so we create a VRF, and then we want to do show run int gig 0001.5, and you can see actually there's another way that you can show IPv4 interface brief. You can actually see here that gig 0001.5 has an IP address of 5.5.5.1. It's up, and then it's in VRFA. And then you can see that we've actually got another sub interface on gig 0001, which is in VRFB, and we'll talk about that in a minute and how it relates into the the BGP and the wider configuration. So where are we then? Let's just have a sanity check. So we've got our loopbacks configured, we've got OSPF configured in a single area OSPF in the global routing table in the core. We advertise the loopback into OSPF and then use the loopback to peer LDP between all nodes that are core facing, including the route reflector. After we've got full LDP connectivity, we then create our BGP sessions. So we start the BGP process on all of the PE nodes, and we peer to the BGP route reflector, which is in this case the VPN v4/v6 route reflector. After we do all that, we then start moving out to looking at peering with the customer. And in order to peer with the customer, instead of using the VPN v4 or VPN v6 address family, we use the IPv4 unicast in a specific VRF for version 4 or version 6. So we're now at that point where we're wanting to create two VRFs, and we want to create two VRFs. So we've created the two VRFs. We've verified which interfaces the VRFs are configured on, which are here, or you can use the the detail command, but it's a bit messy, as you say, a bit if you're not used to looking at the config. But that will tell you what interfaces are in, what the route targets are, things like that. And at the moment we don't have IPv6 configured. So we then the next thing that I want to show you is that we have, if we then go show run router BGP again, and you've seen this configuration before. So the first part of the BGP configuration we looked at, we defined the BGP process, we enabled the address families that we knew that we were going to use. We created an iBGP neighbor in BGP1, remote AS1, update source loopback 0, and then we said that neighbor should operate in VPN v4 and VPN v6 in the core. Now, one thing that's quite tricky in iOS XR to get your head round until you've done it a few times, if you go into the router BGP1 process, if you want to configure IPv4 unicast, what you used to in a VRF, what you would do in iOS XE or traditional iOS is you would go router BGP, and then you would go address family IPv4 unicast VRFA, and then you would go neighbor x.x.x.x activate. It's a bit different in XR, and this isn't really a syntax class, but just so that you know, I'm now in, if I go pwd, I'm in the router BGP1. That's print working directory. So now if I do what I need to do next in order to get into, you see here that this is actually, you know, VRF configuration mode. We then have to go define a route distinguisher, and a route distinguisher, what that does is it makes the routes that you receive in VRFA unique from everything else that doesn't have the same route distinguisher. So you see, this is route distinguisher 1.1. This is route in VRFB, route distinguisher 2.2. If I have a route of 10.10.10.10, right, and I have it in both VRFA and VRFB, they won't collide, because what happens is the route is prepended with whatever the route distinguisher is. So VRFA's route would be 1:1 10.10.10.10. VRFB's route would be 2:2 10.10.10.10. And that's how you know you distinguish route distinguisher. That's how you distinguish. People get mixed up with the route target and the route distinguisher, but they've got two very different purposes. So moving on with the configuration, and what I was going to say is, like, so in order to configure this, when you see this, this is not a VRF underneath a neighbor, it's a neighbor underneath a VRF. So if I was to go VRF, if I wanted to define a new neighbor, I would have to go VRF neighbor 50.50.50.50, and then go on with my configuration. But I don't want to do that at the moment. I just want to show you what I have done. So we've defined the VRF in the global configuration. Then under BGP we go into VRF configuration mode. We define the route distinguishers. We have to tell it again. You know, the fact that we've defined IPv4 unicast, VPN v4 unicast, VPN v6 unicast further up, that's in the global routing table. What we're talking about is the VRF routing table for VRFA. So we have to tell it again. Throughout VRFA BGP configuration, we are going to be using IPv4 unicast and IPv6 unicast. We then say, right, the neighbour that we want to talk to is 5.5.5.5, and the remote AS is 2. So that tells us it's an external BGP peering. Now this router here in the top left hand corner is in remote AS2, and that might be remote AS2 at this site, it might be remote AS3 at this site, or it could be remote AS2 at both sites using allow AS in or AS override, which are two features to allow the BGP speaker to see its own AS come into, you know, the BGP AS path. But back on point, neighbor 5.5.5.5 is effectively CSR5, and it's VRFA's peering, right? We've then got another neighbour which is 55.55.55.5, and that's remote AS2 as well. So to cut to the chase, if I go to CSR5, this is where remote AS2 is. This is where AS2 is. And I do show, first of all I'll do show IP interface brief. There's no IPv4 in this syntax, and you see gig 1.5, so it's a sub interface, and gig 1.55. So that's gig 1 there. I can do show run in gig 1.5, and I can do show run in gig 1.55, and you see here that for the purposes of this demonstration, I've actually, you know, defined VRFs. So interface gig 1.5 is in VRFA, and interface 1.55 is in VRFB, and that correlates and then into the BGP. Show run good router BGP, begin router BGP, and we look at the configuration on iOS XR. So this is what I was talking about, where you go into the router BGP 2, which is here, and then we go under the address family. Once we're under the address family, we say, right, we want to define 5.5.5.1, which is PE1, as the remote AS1. We want to activate the neighbour. There's a command, and then VRFB. We're not advertising any routes from VRFA at the moment, but I've done that on purpose actually to illustrate the difference. So we've got VRFB, and then we're advertising 10. We've got the same config, but we're advertising 100.55.55, all 55s, and you see that is here, and it's loopback 55. So if we then say show run int loopback 55, we can see that we're advertising this route into VRFB. So let's just quickly recap where we are. So what we're saying here is that in the terms of the wider diagram, what we've got is we've got all of our core configured, OSPF, LDP. Let me see if I can get to this original slide. So if we look at the stack, we've got the transport, the physical connectivity in place. We've got the loopbacks. The loopbacks are advertised into OSPF, and then the loopbacks that are advertised into OSPF are being used for LDP label binding and switching and neighbourship. We then got our VPN V4 and V6, and now we've got our VRFs. We've got two VRFs, VRFA and VRFB, and we've got a BGP session running over those VRFs. This concludes part 4 of MPLS VPN building blocks. Please click the link in the description for part 5, where we will bring all components together, test connectivity, and summarise the end-to-end design.